So now we've done some work in Module 1 with solving equations that have a single variable. Now we're going to work on rearranging literal equations. Literal equations are the formulas that you might need to manipulate in order to solve some different problems. So let's look at one literal equation that we all should be pretty familiar with. We see this one every day. Rate equals distance over time. You see this every time you get into an automobile. The rate that you're traveling, so the speed that you're traveling is the distance over the time. In most cases for us, it's miles over hour. So we need to figure out how to manipulate this to our advantage, because sometimes we may not need to necessarily know the rate, but we may already know the rate and the time, and so we would need to know what the distance is equal to. So we need to solve for d, basically, because that's what distance represents, because we already have the rate and time. So in order to do so, I need to look at what is over here with the d and what operation is it performing. Well, the t is dividing the d. So to undo division, I need to do the opposite of division, which is multiplication. So to get rid of t on this side, I need to multiply this side by t, because this will be d times t over t. T over t will cancel out because that is equivalent to 1, and that will leave me 1d, which is what I wanted. So I'm going to bring that right here. Now, I've multiplied the right side of this equation by t, therefore I have to multiply the left side of the equation by t. So t times r, I can just leave that as t times r, which this makes sense. If I'm traveling at a rate of 60 miles an hour for a time of 2 hours, then I would say, okay, my distance is equal to 2 hours times the rate of 60. So 2 times 60 would give me 120. So that's how you might be able to use that particular equation. Let's look at another one that might not be as familiar. Let's look at the equation for the perimeter of a rectangle. That is 2 times the length plus 2 times the width. So let's say that we have a perimeter of, let's go 80. I know that the perimeter is 80, and I know that the length is 30. So you could plug this all in and have 80 is equal to 2 times 30 plus 2w, and then solve for w. That's perfectly fine. But it may be easier for you to go ahead and manipulate this literal equation to go ahead and solve for w before you actually plug in the actual values. So let's look at what we would do there. If we had p is equal to 2l plus 2w, and we wanted to solve for w because that's what we're missing over here, I would need to get rid of this 2l on this right side that is over here with the 2w. That's a positive 2l, so to get rid of it on one side, I need to go minus 2l, because 2l minus 2l is 0, so it is gone on this side. Whatever I do to one side of the equation, I need to do to the other, so I need to go p minus 2l, which I can't actually do, so I have to write it p minus 2l. P's and l's are not like terms, because this was talking about the perimeter and this was talking about the length of the side, so they cannot go together. And that is equal to 2w. Now, this w has a coefficient of 2. That says 2 times w. So to get rid of the multiplication of 2 times, you have to divide this side by 2, because 2 over 2 is equal to 1, so that'll give me the value of 1w, which is what I wanted. And now, whatever I do to the right side, I must do to the left. I can do divide by 2. And then you could leave it like this, or actually be a little bit more correct if you went ahead and reduced it. P over 2 you can't really do anything with, so that will be p divided by 2 minus 2 over 2L, well, 2 over 2, that's equal to 1, so it'll be minus L. And then you can plug in your values of 80 for P, divided by 2, minus the length of 30, equals W. And then we can see, okay, well, 80 divided by 2, that's 40 minus 30. 40 minus 30 is 10, so the width is 10, which may be a little bit easier for you than having to figure out 60 here, and then minus 60 from both sides, and solving it that way. So it's just another option to do if you're given the values of some equation, but it's not quite solved for the variable that you need.